Before we start on domain and range, we need to understand the different notations we can use. If you want to say that x is greater than a, one way to put that is from a to positive infinity. Now, a lot of times this looks like a point, especially when we get over here into our point notation, or say x's between a and b. Okay, this looks like a point, and so this could be confusing. So in general, I prefer this notation right here. You remember, if it includes the point, then you have that equals here, and then this becomes a closed bracket. For closed intervals from a to b, you can write it a is less than or equal to x is less than or equal to b. This is very clear that you're doing an interval. This kind of looks like a point, so just be careful. Now, the other one I want to point out is all real numbers. It literally is from negative infinity to positive infinity. Another way to write this is this big R like this with the two lines. That means all reals. So the domain of the function is the set of allowable x values. What you want to look at is restrictions. You're going to want to look at taking the square root of a negative number. Okay? All right, in general, you're going to take whatever your argument is. So if you have the square root of some f of x, and you're going to find out when f of x is greater than or equal to 0. All right, and that will be your domain. The other thing you want to look at is denominators. Your denominator cannot equal 0. So to find restrictions on your domain, set your denominator equal to 0 to find that restriction. Let's look at this function right here. It has no radicals. It has no fractions. It has no denominator that could become infinite. So for this function right here, the answer is all reals, or from negative infinity to infinity, if I'm looking for the domain. That's what I'm going to be looking for the next couple of problems. Now, what's the domain of this? Well, you look at the denominator, you set it equal to 0. So x minus 6 equal to 0 when x equals 6. So there are two ways you can write this. You can say the domain is all real numbers so long as x does not equal 6. Or you can put this one in the interval notation, negative infinity to 6, union, remember your union, 6 to infinity. Now if I look at this function right here, I need to find out where is x plus 5 greater than or equal to 0. So the domain of this function is for all x greater than 5. So this would be 5 to infinity, and it's very clear that this is an interval notation for all x greater than or equal to 5, which is what I've already put up here. Now, when you have an odd root, it turns out you have a domain of all the real numbers, because it's okay for this to be negative. Now, the range is the set of allowable y values, and this one can be a bit of a challenge. Let's look at this function right here. Y equals 1 minus x squared. Now, you know this is a downward pointing parabola. All right, if I were to sketch this very quickly, when x is 0, y is 1. And then this is going to continue and go down at, okay, this is going to be symmetrical. This is negative 1, and this is positive 1. All right, so the range for this function is all x from negative infinity to 1, and that is inclusive. So the range, you could also put it as, oh, that's a good way to put it. Now let's look at this function right here. All right, this is a graph, and all we're going to do is look at the graph and see if we can find the domain and the range. Now it's quite obvious the x values they keep going on, so for the domain, there seem to be no restrictions on the x value. But what about the range? All right, The maximum y value is up here, and I know it's very hard to see on this graph, but it's 2.5. And this number right down here is negative 0.5. So the range for this function, and I don't want that, I want brackets. It's going to go from negative 5 to 2.5, and it's inclusive. Now, if you were using a calculator and this was on a test, you would need to actually go up there and verify that. Similarly, let's look at something like this. When I have this open, that means it does not include that point. So the domain for this function is from 0 to 4, but you see it's not including those points. While the range, let's see, the range, does it include 0? Yes, it does, because this function has a value right there of 0. And it goes all the way up, but it does not include 4.